So starting with this table of values, we want to be able to come up with a picture or graph, and we also want to be able to come up with an equation. And again, the two things that we need to look for then are the starting position and the angle at which it goes up by, or the slope. So let's first graph this expression, or this relationship. So -6, +5, point right there, -2, +3, 0, 2. So it looks like it's going from left to right down, which means then that the slope must be negative. This is going to be 8 over -2 down. Okay, so it definitely looks like a straight line relationship, so we should be able to have a slope or proportional change, and we need to find the positioning of this. Okay, so there's my straight line pattern. So we want to find the changes in y compared to the changes in x. So changes in y, we're going to look for it in a table. So here it's gone down 3, okay, and it's going up from -2 to +4. There's a +6 change for the change in x. Okay, so this represents my change in x. This represents my change in y. Was going to be -3. The ratio of change in y to change in x is -3 to +6. Okay, so how does this show up in the picture? Well, it shows up in my picture in my slope triangle. So it's going to be -3. So the change in y equals -3. The change in x is going to be here, and that change in x happens to be +6. Okay, so it shows up. Where does it show up in the picture? In the slope triangle. Okay, so I'm going to highlight that slope triangle. There it is. Okay, in the slope triangle. What other part do we really need to find? We need to find the starting point. Well, we have the starting point showing up in the table and also in the picture. Okay, so this one doesn't ask us to come up with the equation, but we know there must be some equation that relates to this. And how do we show that +2 y-intercept and slope of -3 to 6? In fact, maybe I will simplify that as well. So the slope is my change in y over the change in x. Okay, and we know that's going to be -1/2. Okay, so it goes down 1 over 2, down 1 over 2. Okay, so we haven't been asked for the equation, but how can we put the slope and the starting point into an equation? Okay, so here's another problem here. So this time we want to come up with the equation. So we have the word expression, or word relationship. So it says the cost of the team going to a trampoline park and the number of kids that go. So reserving the park is going to cost $50, and it costs $14 for every child we're going to bring. So the two quantities we're going to relate are the cost and however many kids come. So cost is our dependent variable, and the cost is calculated for each child. So what's the fixed cost here? The fixed cost is going to be $50. So that's our starting point. And how is this going to grow? It's going to grow by $14 per child times the number of children. Okay, so what's this as an xy equation? It's going to be y equals 50 plus 14x. What's the ratio of change? The ratio of change, well, we could draw a table of values. We can draw a picture of this, but maybe we can relate the ratio of change to the equation. Okay, the ratio of change is that multiplier times 14, and it shows up in my word equation as a rate. Okay, so that is a rate. So this is a rate in the problem. Remember, if there's a constant rate, that often characterizes a straight line relationship. So the ratio of change is $14 for every child, for one child. Okay, or as a rate, we write it as $14 per child. What's the ratio of change related to? It's related to the rate in the problem. So it is related to the rate in the problem. Okay, and that's our $14 per child. The last part of this is, what is a fixed cost before any kids go? So the fixed cost is $50. That's how much we have to pay even if 0 kids go to this trampoline park. Just to reserve it, we have to pay $50.